Okay, so here we're trying to calculate the wavelength of a line in a spectrum of hydrogen. Now these questions are a little beyond what we saw in class. Here we got n equals 7 equals 12. There's several different formulas. Sometimes you got a negative sign in there, sometimes you don't, that you can use when solving this. And even ALEKS provides an equation here that's different than what we saw in class. So just to keep things consistent with class, I'm going to use the formula I gave you, which is energy equals 2.18 minus 18 joules. And we want this to be positive, so we're actually going to use the smaller n first. So here, this will be a 7, and then this one will be a 12. So what we have here is 1 over 49 minus 1 over 144. I'm going to do parentheses, so 1 parentheses 1 over 49 parentheses minus parentheses 1 over 144, and I get that to be 0.01346. Now I'm going to multiply that by the 2.18. I'm going to use my EE button, negative 18. So I get my energy is equal to 2.935 times 10 to the negative 20th joules. So what is the wavelength for that? So then we got to use our equation. If we start with E equals hc over wavelength, we can rearrange that, multiply both sides by wavelength, divide both by energy, and we get wavelength equals hc over energy. So that is 6.626 times 10 to the minus 34. Times 3.00. And then we put our energy that we just solved for, 2.935. Check our units, joules cancel, seconds cancel. We're left with meters, which we'll have to convert to micrometers. So we put that all in. I'm going to use my EE button again, 6.626 EE, negative 34, E times 3 EE, the 8, and then divided by 2.935 EE to the negative 20th. And I get 6.773 times 10 to the minus 6 meters. Now a micrometer is 1 times 10 to the 6th. Meters, so I go 1 meter. So I'm going to multiply that by 1 EE6, and I get 6.77 microns. Is the wavelength of our transition from 12 to 7. So pretty low energy compared to some that are in the nanometers. As it's, the energy levels get pretty close together when you're up in those high 12s and 7s. And so not as much energy involved when you're going in those higher transitions. So let's plug that in. There we go.